Download this code from codegive.com, link in the description below. Civet, a beautiful attempt to fix TypeScript, a deep dive and tutorial. Civet is a relatively new language that aims to improve upon TypeScript syntax and developer experience while maintaining full compatibility. It's essentially a preprocessor that transforms Civet code into standard TypeScript, leveraging the existing TypeScript ecosystem for type checking, compilation, and tooling. Think of it like CoffeeScript, but for TypeScript. This tutorial will provide a comprehensive exploration of Civet, covering its motivations, key features, advantages, and how to get started. We'll sprinkle in plenty of code examples to illustrate the concepts. Why Civet? Addressing TypeScript's pain points. While TypeScript is a significant improvement over JavaScript, it still has some areas that developers find cumbersome or less than ideal. Verbosity. TypeScript can sometimes be verbose, especially when dealing with complex type annotations, particularly when those annotations are frequently redundant and can be inferred. Ceremony. Modern JavaScript syntax, ES6+, has some ceremony, example explicit return statements, this binding, that can feel unnecessary in a language built on top of JavaScript. Consistency. While TypeScript does its best to be consistent with JavaScript, there are still some discrepancies that can lead to confusion. Expressiveness. Certain common patterns or idioms can require more code in TypeScript than feels ideal. Civet aims to address these pain points by offering a more concise, expressive, and enjoyable syntax while remaining fully compatible with existing TypeScript code and libraries. It provides a smoother and more natural transition from JavaScript for developers who aren't yet familiar with type systems. Key features and syntax highlights. Let's delve into the core features of Civet that make it stand out. We'll use TypeScript code snippets as a baseline to demonstrate the Civet equivalence. 1. Implicits, type inference on steroids. Civet heavily leverages TypeScript's type inference to eliminate the need for explicit type annotations in many cases. This can dramatically reduce boilerplate. TypeScript asterisk. Civet asterisk. Asterisk explanation asterisk. Asterisk Civet infers that a and b in the add function are numbers based on the plus operator. Asterisk it also infers that add returns a number. Asterisk similarly, result is inferred to be a number because it's assigned the result of add. 2. Implicit returns and expression bodies. For simple functions, Civet allows you to omit the return keyword and use an expression body, making the code more concise. TypeScript asterisk. Civet asterisk. Asterisk explanation asterisk the expression x asterisk x is implicitly returned by the square function. 3. Automatic this binding. Civet simplifies working with this in classes and object methods. It automatically binds this to the correct context, eliminating the need for .bind, this, or arrow functions to preserve this. TypeScript asterisk. Civet asterisk. Asterisk explanation asterisk. Asterisk the set timeout callback automatically retains the correct this context, i.e., the counter instance. Asterisk at count is a shorthand for this .count. Civet treats methods called on at specially, ensuring the correct this binding. Asterisk the do keyword creates an inline function in Civet. 4. Simplified object literals. Civet offers a more concise syntax for defining object literals, particularly when property names are the same as variable names. TypeScript asterisk. Civet asterisk. Asterisk explanation asterisk if a property name in an object literal is the same as a variable name, you can simply use the variable name as the property name. 5. Shorthand array creation. Civet provides convenient syntax for creating arrays, especially when generating a sequence of numbers. TypeScript asterisk. Civet asterisk. Asterisk explanation asterisk. Asterisk the 1 to 5 is a civet range literal, generating an array of numbers from 1 to 5, inclusive. Asterisk it's roughly equivalent to Python's range, 1, 6. 6 list comprehensions, simplified. Civet simplifies the creation of new lists by filtering and transforming elements from existing lists. TypeScript asterisk. Civet asterisk. Asterisk explanation asterisk the number asterisk number for number in numbers when number %2 == 0 creates a new array by squaring each even number from the numbers array. 7 Elvis operator, safe navigation. Civet includes an Elvis operator for safe navigation through nested objects, preventing errors when accessing properties that might be undefined or null. This is also part of modern JavaScript, but Civet embraces it. TypeScript asterisk. Civet asterisk. Asterisk explanation asterisk the ensures that the code doesn't throw an error if any of the properties, profile, address, city, are null or undefined. It returns undefined if any of those properties are missing. This is native to JavaScript now as well. 8 Do blocks. Civet's do block is a very versatile feature. TypeScript asterisk. Civet asterisk. Asterisk explanation asterisk a do block allows executing a block of code and returning the last expression's value implicitly. This is useful for inline conditional logic and simplifying complex assignments. 9 Destructuring assignments with type hints. Civet makes destructuring assignments more concise and type-safe. TypeScript asterisk. Civet asterisk. Asterisk explanation asterisk Civet provides a clean and compact syntax for destructuring. You can still provide type hints when needed. Getting started with Civet. 1 Installation asterisk. Install Civet globally using npm or yarn. 2 Creating a project asterisk. Create a new directory for your project and initialize a TypeScript project, if you don't already have one. 3 Configuring xconfig.json asterisk. Modify your xconfig.json to allow JavaScript files in your project and set the out dir where you want the compiled JavaScript to be placed. 4 Creating a Civet file asterisk. Create a file named src/main.civet, or any other name with the .civet extension, and add some Civet code. 5 Compiling Civet asterisk. Compile your Civet code to TypeScript using the Civet command. This will generate a dist/main.ts file containing the equivalent TypeScript code. 6 Running the code asterisk. Run the compiled JavaScript code using node.js. You should see Hello, Civet, printed to the console. Integrating with build tools, Webpack, Parcel, Rollup. To use Civet in a larger project with a build tool like Webpack, Parcel, or Rollup, you'll need to configure the build tool to process .civet files. This usually involves using a loader or plugin. Here's a basic example for Webpack. 1 Install Civet as a dev dependency asterisk. 2 Configure Webpack asterisk. Modify your webpack.config.js to include a rule for .civet files. Install the Civet loader and TS loader. You could also use Babel loader and use @babel/preset TypeScript, as the Civet loader outputs valid TypeScript that other loaders can process. 3 Create src/index.civet asterisk. 4 Create src/utils.civet asterisk. 5 Run Webpack asterisk. This will bundle your Civet code into dist/bundle.js. Pros and cons of Civet. Pros asterisk. Asterisk improved syntax. Asterisk more concise and expressive syntax compared to TypeScript. Asterisk reduced boilerplate. Asterisk implicit types and returns significantly reduce boilerplate code. Asterisk full TypeScript compatibility. Asterisk generates standard TypeScript, ensuring compatibility with existing libraries and tooling. Asterisk simplified this binding. Asterisk automatic. This binding eliminates common this related headaches. Asterisk developer experience. Asterisk aims to provide a more enjoyable and productive development experience. Cons. Asterisk another layer of abstraction. Asterisk adds an extra step in the build process, Civet compilation. Asterisk debugging complexity. Asterisk debugging can be slightly more complex as you're working with Civet code that's transformed into TypeScript. Source maps help mitigate this. Asterisk community size. Asterisk smaller community compared to TypeScript, which means fewer resources and less community support, at least for now. Asterisk learning curve. Asterisk requires learning a new syntax, although it's relatively straightforward for TypeScript or JavaScript developers. Asterisk overhead. Asterisk Civet is a transpiler. While the output is TypeScript, it still adds a transpilation step. Conclusion: is Civet worth it? Civet is a promising attempt to address some of the pain points of TypeScript and make the development process more enjoyable. Its concise syntax, reduced boilerplate, and simplified this binding can significantly improve developer productivity, especially on large projects. However, it's important to weigh the benefits against the potential drawbacks, such as the added complexity of another build step and the learning curve of a new syntax. If you're a TypeScript developer who's looking for a more concise and expressive language while maintaining full compatibility with the TypeScript ecosystem, Civet is definitely worth exploring. It can significantly reduce the amount of code you write and make your code more readable. If you're relatively new to TypeScript, mastering the base language first before introducing Civet might be a better approach. As the Civet community grows and the tooling matures, it has the potential to become a compelling alternative to TypeScript for many developers. It really depends on whether the syntax resonates with you, and whether the trade-offs are worth it for your specific project needs. Experiment, play around with it, and see if it clicks.